Well, here we are again, live. Well, it may have been live at one point. Um, this is part two of week six of cis204 Unix shell scripting and utilities, and we're discussing interactive bash. And I told you we'd be moving forward, but I'm going to move backwards a bit. We talked about the init process and how you could work your way back based on where you're at by looking at the process ID, which is this thingy right here, and the parent process ID. So here I have the process ID of the bash shell being 3115, the parent 3105. The parent of the GNOME terminal 3105 is 1884. 1884 is the init-user process. 1535 is its parent. 1535 points to 1432, which is that LightDM process. And then 1432 points to the init. Well, looky here. I did a ps-ef and I grepped for myself. Found that 3541, that points to 1320, but that's that's secure shell, so I'm not going to monkey with that. Let me go to this one, 3560. There I am on that pseudo terminal, and it points to 3541. So 3560 points to 3541, 3541 points to 1320, 1320 points to 1. Okay, so that's how that works. Now, back to work. So, environment variables. The shell is going to use a number of startup files that enable settings. In other words, you wonder where your path comes from. It comes from the environment variables that are sitting there. The startup files are sourced, and it's kind of an interesting process. But basically, you're executing a shell without creating a new shell. That's how they're sourced. You're executing the shell inside the current shell. The startup files are sourced. Sourcing causes the settings in the file to take effect, and they'll take effect inside the current shell. And then there are some system-wide user startup files that are invoked, and then there are some user-specific startup files that get invoked. And that's anytime you log in as bash. So there is an /etc profile. It's a system-wide initialization file that's set up by sysadmin. And there's an example in 13.4 Unix shells by example. And then we're going to review what's sitting in the setup on CentOS image. So let's go back over here. Let's do this. More /etc profile. So system-wide environment startup programs for login. So function and aliases will go in the /etc bash RC. I love this. It's not a good idea to change this file unless you know what you are doing. It's much better to create a custom.shell shell script in the /etc profile.d to make custom changes to your environment. Not everyone's environment, but your environment, as this prevents the need for merging all of these odd duck things in the future. Well, the first thing they've got is this path munge statement. And the case in $path, you're going to basically be building a path statement. So let me move forward here. Then it looks for whether the user bin ID is executable. If it's a non-zero, the end user ID, then k-shell workaround. User is going to equal the ID space -un. And let's take a look at that for grins. So let's do an ID-un. Okay, let's just do an ID. Well, the UN is the username. Okay, so the log name is going to be set to this user. So user equal, and the log name is $user. So echo dollar, well, let's just issue the, echo dollar log name. Let's see what we get here. That's what I expected to get. Echo dollar user. Let's see what we get here. Yeah, same thing. Okay, imagine that, but it worked. So path manipulation, they're going to do this path munge again on user local and user sbin. So here's the history. Host name is going to be set to whatever the user bin host name is. So if I, which host name, for instance, bin host name, ls-l bin host name for grins. And it's in bin host name, but we'll see where it's at elsewhere. So if I do an issue, if I just issue the command host name, it tells me the name of the machine. Okay, so there's a number of things that get set up. Your umask, which we'll talk about later, and this unset the -f path munge. So let's jump out of this real quick and go forward. So here's this goofy little snippet from the file. So it's looking for in the etc profile.d anytime there is a .shell. So let's do this. Let's list etc profile.d. Those are the shells that are inside etc profile.d. Anytime it finds a .shell in there, it's going to check to see if that .shell has a readable, whether or not it's readable. And then if this string, this odd duck dash splat star I, which is whatever that .shell name is, then is not equal to $dash, then source the $I, else source the $I and send the output to dev null. So what is $dash? Let's echo $dash. And that's where we get this himbh. Okay. So what does that do? Well, I don't want you to echo this $splat dash and whatever the contents of I are, because that's a little odd. But this is what the himbh that we just saw. So what is it? Echo $dash, and I get this himbh. H is short for hash all. That tells Bash to remember the locations of commands it has found through querying your path. In other words, it's going to put a list of paths for commands in memory. I, short for interactive, which is good because, you know, you're in the shell which you're interacting with. In other words, you're entering input and getting back output. M is short for monitor. That enables job control in Bash, so you can send jobs to the background via BG, which is another way of sending a job to the background other than using the ampersand at the end of the command line. The capital B is short for brace expand. That allows you to use the very efficient brace expansion that's sitting in Bash 2, which is Bash 2 and above. And the capital H is short for history expand. That's what enables you to rerun a command from your history by prefacing its number with an exclamation point. So if I type this, let's do this. Let's do a -hist. History. Let's see here. There are all my history commands. For instance, I want to 1024. That should give me this echo $dash. Sure enough, it says echo $dash, and there it is. Okay. So that was fun. So here's a stupid shell trick. If you make dir playground, so let me capture this. Let me do this. Make dir playground. So let me clear the screen. Let's just ls where we're at, make sure that nothing like that already exists. I'm going to paste that in. So now I have a directory called playground. So what am I going to do next? Well, I'm going to go into the directory playground. I'm going to cd to playground. And I'm just copying and pasting because I'm copying and pasting. It's actually cheaper to go cd space pl and then hit the tab key. So let me do this. Let me make this set of directories. But what does this thing do? Well, it's going to make directories. It's going to create a test1, a test2, a test, a test ABC, a test splat, and a test.txt directory. How do I know that? That's how I know that. How now? Let's take a peek here. How do you remove that test splat? How did that happen? If I remove dir test splat like that, I don't have anything left. Oh man. Let's make that set of directories again. How do I remove test splat? Well, would you believe? RMDIR, you remove it the same way you created it. Escape, splat. It's gone. All right. Remove dir test splat. Now they're all gone. Okay, good. So, what did we learn? We learned that these curly braces around makedir allow you to create a directory with a common prefix and different names inside. So in this case, I created a test1, a test2, a test, test ABC, test splat, test.txt. Those directories existed. There they were, test splat, test1, test2, test ABC, test, test.txt. And then by using this escape character, we were able to successfully remove just the test splat. When we did an RMDR test splat, it removed all of the directories because remember that splat's a wildcard. Okay, back to work. So how about I need to make 16 directories for each week of the class? Well, you're already there in Playground, so why don't you do a makedir week 0.16? So that'll make directories week 0 through 16. But if I did this, makedir week 1 dash up dot dot, and it's dot dot, it's not dot dot dot, it's not dash, it's not comma. If you want 16 directories starting with 1 ending with 16, it's the number dot dot the final number. So what did I end up with? There they are. Week 1, 11, 13, 15, 2, 4, 6, 8, 10, 12, 14, 16, 3, 5, 7, and 9. Let's do an ls-l. There they are. Now, notice how the system deals with the position of the number. So 1 is higher than 2. 10 is also lower than 2, in this case, lower numerically than 2 because it's positional. It just starts with that first position. So how do I remove those? Remove dir week splat, right? What have I got left? Nothing, which is what I expected. Okay, so that works. Path munge. Cool, but what the heck is a munge? So the snippet of script that we saw in that profile, Etsy profile, is path munge. It uses a word that isn't in the dictionary. So it's not a word, it's not in the dictionary, it's munge. Mung, or munge, is computer jargon for a series of changes to a piece of data, which are often well-defined and individually reversible, but which transform the original item into an unrecognizable form. It's the old telephone game. You start with one word whispered into the ear of somebody else, and eventually you get around to the first person, and the word is no longer what it was when it started. It was changed along the way. The changes may be destructive, e.g. by corrupting the file or simply concealing. In other words, changes to an email address to disguise it from spam bots. So the term was coined in 1958 in the Tech Model Railroad Club at the Massachusetts Institute of Technology. Now, again, we're dealing with geeks, and geeks love puns. So in 1960, the backronym MASH Until No Good was created to describe Mung. And after a while, it was revised to Mung Until No Good, making it one of the first recursive acronyms. It lived on as a recursive command in the editing language Techo. And Techo, as we saw earlier, was part of this whole process. So there you go. Now, back to work. So this is our bash profile. Let me take a peek here. So let's clean this screen up. And let me cd ... and remove the directory playground. Okay, there we go. Now, I did an ls. Where is my .bash profile? ls-la.b splat. Show me the .b's. Well, there we go. I've got a bash RC, a bash profile, a bash logout, and a bash history. So there's my bash profile. So let's take a look at what's in that. Actually, not much. So it's found in the user's home directory and allows the user to customize the shell. If at startup that shell .bash profile doesn't exist, it will look for a .bash login. If that doesn't exist, it will look for a .profile, which is the old K-shell profile. Bash will also check to see if there's a .bash RC file to source. Now, we could go through these examples 13, 5, 6, 7, and 8. We'll do that in class. Let's look at this. So what have I got? There's my pass statement, and that's about all I have in the bash profile. But notice what it does. If the file exists, .bash RC, then source that. So let's do a more on .bash RC. Notice I've done two things in my bash RC. I've set an alias. The letter M is equal to the command less, and the letter L is equal to the command more. And you may know why that is. So, how do we do additional customization? Well, we use the .input RC. If it exists, and it won't by default, it is sourced. Now the fun thing is the .input RC contains variables that customize keystroke behavior. In other words, all those function keys sitting at the top of the keyboard that you may not use can be set. You bind strings, macros, and controls to the function keys. Key binding definitions are found in the readline library. The readline library? Man, readline. No manual entry for readline. Okay, so the CentOS does not have that. Let's see what we've got here in Ubuntu. Man, readline. We've got readline in Ubuntu. Okay, so again, your distribution is going to determine whether or not something exists. So you've got to be careful with these things. The bindings are used by the built-in Emacs and VI editors when performing command line editing, and God forbid that we mention Emacs again here. So another thing, set-O options. They allow the customization of the shell environment. You can do them a couple of ways. Set-O's option name form or an abbreviated option form. So there's a table on page 64 of Unix shells by example that you can look at. So you can set -O VI, which changes the input editor, the command line editor, to be VI instead of the built-in editor, which kind of resembles Emacs with bash. And you can unset it with the set +O VI. So we'll talk about the examples in class. So here's an example of all export. So I want to create the following shell using VI. The first is export 1, the second is export 2. Why am I doing this? Well, we'll see in just a minute, because I'm about ready to start part 3 of cis204 Unix shell scripting and examples, week 6. Talk to you again in just a minute.